Hey everyone, in this video we will be going to learn about data visualization topic in machine learning. So in the name itself, we can easily say the visual representation of data is known as data visualization. So the data visualization is the graphical representation of the data. We can use different graphical representations like charts, graphs, and many other to represent the data in the visual forms. The main uses of data visualization is to find the patterns and trends, which means it quickly shows what data is telling us, and we will be able to take better decisions by seeing it visually. It also helps us to improve better communication so that we can easily communicate with others by showing it visually. It will make the data very easy to understand. So the real world applications of data visualization includes business sector, where we will be representing the market trends, sales performances visually, and also in healthcare. We will be using data visualization in healthcare to monitor the patient details and to track any diseases. And also we will be using data visualization in finance sector. We will be representing the stock market analysis and many other different activities visually. Education will be visualizing the students' performance, and also in social media we can represent different emotions and different activities of the person visually. So the common types of data visualization includes different charts like bar charts, line charts, pie charts, and many other. We can use a variety of techniques to represent the data visually according to our needs. So here is the pictorial representation of data visualization charts, where you can use many of them to represent your data according to your needs. Here are some. To perform data visualization, we need to import some of the important libraries. Without libraries, we cannot perform data visualization. So the main libraries which we will be using to visualize are matplotlib, seaborn, pandas, plotly, and many other. These are basic libraries which will be very easy to use. By using this, we can perform basic plotting and we can create interactive dynamic visuals. These libraries are very great for statistical data visualization. So here I have considered an iris dataset which contains three species named as Setosa, versicolor species, and virginica. In the dataset, I have the properties like length, sepal width, petal width of individual species. Along with that, we have the count values, mean value, standard deviation, minimum value, and many other. So the data set I have taken is represented in the bar graph representation. Here on the x-axis I have taken individual species, and on the y-axis I have taken average sepal length of each individual species represented in the bar graph. So this is how the data set is represented visually. So for our practice, we can import datasets from wide variety of platforms which offers dataset for free and also some of them for paid. The free offering websites are Kaggle, Google Datasets, AWS Public Datasets, and many other. We can freely import the dataset or we can download it from these websites to use them. First, you need to visit the website and search for the required dataset you want and download it in the formats like CSV, JSON, or Excel. After download it, first you need to clean the dataset so that you can ensure that there are no missing values or duplicate values in order to perform better visualization. After cleaning the data, import necessary libraries and convert them to visual forms. So importantly, check whether the dataset is free or not for your practice. So up to now, we have seen So up to now we have clearly learned about the data visualization theoretically. Now let us know how to visualize it technically. For that I will be opening my collab. So after opening the collab, firstly I imported all the necessary libraries. Here to visualize I imported pandas, matplotlib and seaborn libraries. to visualize my data. Now let me run this. So after importing, I have taken iris dataset as example and loaded it. So the dataset has been loaded. Now I'll be displaying the dataset. So to display, we no need to require all the values. So simply import few rows. So simply display few rows. To display first few rows of the dataset, I have used iris.head, which will return the first 5 values of the dataset, and also I have displayed basic statistics of the dataset. So here is the required dataset. Here we have written the properties sepal length, sepal width, petal length, and petal width of the 3 individual species, and these are the basic statistics: count, mean, standard deviation, minimum value, and the percentages and the maximum value. Now let us visualize this dataset. Firstly, with the pair plot. To display pair plot, I have used Seaborn library, and the title of the pair plot will be pair plot of this iris dataset, and I'll show how this works. So here is the pair plot visualization. Here we have 4 properties: sepal length, sepal width, petal length, and petal width. So here each color represent each individual species. Blue color represent Setosa, orange color represent versicolor, and green color represent virginica. So here is the data. 3 individual species are represented in each graph. Here the species have more sepal length, and here both versicolor and virginica are having similar sepal width, and here the highest petal length is Setosa, and the petal width is highest and the petal width is maximum in Setosa species. Now we'll visualize box plot. For that I have given the size of the box with length 10 and breadth 6. I have used Seaborn library where x-axis contains species and y-axis contains sepal length, and after running it, so here is the box plot representation where sepal length is printed by individual species. The sepal length of Setosa is in between 5 and 5.5, and the versicolor sepal length is in between 5.5 and 6.5, and the virginica sepal length is between 6 and 7 below. And after box plot, we will visualize scatter plot. For that, I have given figure size 10,6 as length and breadth. On x-axis, we have taken sepal length, and on y-axis, I have taken sepal width. And we will be printing sepal length versus sepal width of the species. Here, let me run it. So this is how scatter plot will be visualized. And the line which is in the middle is a regression line. The line above and the line below shows the highest value and the minimum value of the sepal length and sepal width. Both are both are represented in scatter plot. So the next visual representation is histogram. To create histogram, I have given size of length 6 and breadth 10 and used Seaborn library. On X label, I have given sepal length. On Y label, I have given frequency of the species, and let me run it. So here is the histogram. On x-axis we have sepal length, and on y-axis we have frequency of each species. This line shows how the sepal length and frequency increased along the way and also decreased when it comes to end. This is how we can represent histogram. Next, be showing Next, I will be showing how violin plot can be represented. For violin plot, I have given figure size 10, 6, and on x-axis we have species, and on y-axis we have sepal length. And let me run it. We can also save it by using save figure, which will be automatically saved. So here is how violin plot is represented. On x-axis we have three different individual species, and on y-axis we have sepal width of these species. Next, I'll show how to implement bar plot. Here also I have given same figure size 10, 6, and on x-axis we have species, and on y-axis we have sepal length. So here we have taken the average sepal length. Here we have to show average sepal length by each individual species. For that, the formula will be total sum by individual length. So here is the formula. X represents total sum by individual length. Total sum length by individual length. On Y label, we will be having average sepal length, and on X axis, we will take individual species. After running this, we will get bar plot like this. So here we have three individual species, and on y-axis we have calculated already average sepal length, and according to the average, the bar plot will be printed like this. So the average sepal length of the species Setosa is 5, and the average sepal length of versicolor species is 6, and the virginica is under 7. So next, heat map. This is also an interesting visual representation. To implement heat map, first we need to load the dataset. Here I have loaded dataset by using the library Seaborn, and after we need to print data values in the dataset by using iris.head. We will print the values for our clear understanding, and after printing, the value should be integer type and float because the numerical values are represented in the heat map. After selecting the data type, we have to calculate the correlation matrix for the heat map. To calculate correlation matrix, we will be using numeric iris dot correlation. After correlation matrix, we will be given size of the figure 10, 8, which is length and breadth. And by using Seaborn library, we will be representing the colors of heat map in form of cool warm. Cool warm means it will contain different colors with different values. So after running, I have the data set. I have printed the values, first 5 values. This is how heat map is. The darkest color. Here, one dark red represents the highest value, and the dark blue color represents the lowest value. As here I have shown, the darker color represents the highest value, and coming down, we have the minimum values. Here we have represented 4 properties with 4 different colors. The next plotting technique is phase grid. Phase grid is a technique used for individual representation. Here firstly we have loaded Seaborn library and declared the species with height 4, and the properties which are needed to be visualized are sepal length and sepal width. To print individual species sepal length and sepal width, we have to declare sepal length versus sepal width by species, which will return individual sepal length and sepal width of the species. To save the result, we can use save figure. After running, here is how phase grid is implemented. We have each individual species, Setosa, versicolor, virginica, and also individual species with their properties sepal width and sepal length. Here we have sepal We have three individual species with their properties sepal length versus sepal width. And next, box and plot. Box and plot is similar to box plot, which we'll be implementing same as box plot, but in a more visualized way. Here also I have declared figure size. On x-axis we have species, on y-axis we have petal length, and after running it, this is how box and plot represent. Same likely as box plot, we have also three individual species and petal length of these species is represented like this. To save any of the above images, we can directly import files from this collab and we can download by using files.download. So it is downloading the images. See, it has downloaded. You can clearly allow and you can save them. So this is how iris dataset visualization. So here we have taken different graphical representation. Each of them have different properties. Either we can represent them individually or we can represent them grouply. Let me take another example. For more understanding, here I have taken another example, adult income. Firstly, we need to import a library. Here I have imported pandas for visualization and I have directly taken dataset with the URL. Either you can take file format or you can directly import them. And the statistics data is age, work class, education and some other. Now let me print the dataset. Here is the dataset. We have different properties, age, work class, and many other. Here is the complete dataset. We'll be visualizing the dataset values based on the income, who is less than or less than 50,000 and above 50,000. First, we need to clean the dataset. For that, I will be performing data pre-processing. First, I will be checking null values, and if any null values are there, I will be dropping the rows which contain null values. So null values, duplicate values and missing values all are clear. I have clean dataset. Now I will perform visualization. So I'll be representing count plot for income distribution. First I have loaded Seaborn library, Matplotlib library and PyPlot for visualizing. Next I have given figure size 10,6 which is length and breadth. On x-axis I have income and on y-axis I have count. Now let me run it. So here is the income distribution. The income distribution is done basically on less than or equal to 50,000 and greater than 50,000. So here less than 50,000 the count is under 25,000 and greater than 50,000 the count is above 5,000. Another representation is box plot. Here also same I have taken on x-axis income and on y-axis I have taken age. Let me run it. So the age distribution by income. Less than 50,000 or equal to 50,000, the aged members are in between 40 and 50, and above 50,000, I have the age members between above 30 and below 50. Now we will be representing bar plot by taking education level and income. Firstly, I have declared figure size 12,6 on income. First, I have taken figure size 12,6 and on x-axis we have education and on y-axis we have count. Based on education level, we will be representing bar plot. So after running it, we have representation like this, where blue color indicates the income of the people who are under 50,000 and orange color indicates the income is above 50,000. So here the bachelors who are under 50, the bachelors whose income is 50,000 is in between 2,000 and 4,000, and the bachelor whose income is greater than 50,000 is above 2,000. Based on the education level, But taking income as consideration, we have given the count representation in the form of bar plot. So this is how we can visualize the data simply for clear understanding. I hope everyone understands it. Thank you.